Move over, James Webb. Hubble is back in town, and it's made an astounding new discovery. The story of this discovery involves the Hubble Space Telescope, a very distant galaxy, and gravitational lensing. Hubble has been observing the universe for over 30 years at this point, and the team behind it have just made another very exciting announcement. In an image they released on March 30th, 2022, they discovered the most distant individual star that we've ever observed. They've named it Earendel, which NASA tells us means morning star in Old English, and they say it has nothing at all to do with the Silmarillion. Who are they trying to fool? Nerds are gonna nerd. This new, well, old, star existed when the universe was only about 900,000 years old, which sounds like a lot, but it's only about 7% of the current age of the universe. This means that the light from this star has been traveling for an absolutely outrageous amount of time, 12.9 billion years. It's been traversing the universe for so long, and eventually those primordial photons made their way into the Hubble Space Telescope. And now we're seeing them on our screens, and this is absolutely incredible to me. Also, if you're wondering why the foreground star in this Hubble image has 4 spikes coming out of it, I have a video all about this effect. You can click in the card up here or in the video description to learn all about these so-called diffraction spikes. Earendel becomes the record holder for the farthest individual star that we've ever seen, and it absolutely smashed the previous record from 2018. Back then, the Hubble telescope peeped at a star that was around when the universe was about 4 billion years old, which is still an incredibly long time ago, but nowhere near as long ago as the new record holder Earendel. The previous record holder was named Icarus, so let me know in the comments below which one of these record-breaking stars you think has the coolest name. Actually, we have seen objects that are more distant than Earendel, but never an individual star this far away. We can normally only see entire galaxies at these incredible distances, and that's simply because they're so much brighter than individual stars. A galaxy is a collection of billions of stars, and the first galaxies were just starting to form at this time, so you can easily imagine how much brighter they are than an individual star. Previously, the smallest objects seen at this larger distance were clusters of stars inside galaxy, still many times brighter than a single star. Despite the huge increase in brightness, even galaxies are only faint smudges at these distances. So how the heck did Hubble see a single star so far away? Well, it requires a delightfully helpful cosmic lineup, a bit of luck when we look out into space. Don't be fooled though, the fact that we've seen this doesn't mean anything particularly special. Hubble is looking at millions of objects, and there are literally trillions of objects in the observable universe. So the fact that we finally caught some in the perfect configuration for this isn't remarkable, it's just statistics. The cosmic coincidence I'm referring to is that between Earendel and the galaxy it lives in, and us, there is a cluster of galaxies, named with the catchy title WHL 0137-08. Sure. And this cluster is gravitationally lensing the entire galaxy that contains Earendel. This means that the huge mass of the galaxy cluster that's in between us is distorting and magnifying the light of Earendel's galaxy, causing it to appear brighter than usual, and also have a very long crescent shape. The galaxy isn't really this shape in reality, but we see it like that due to the gravitational lensing. Just in the same way that glass can lens light, this galaxy cluster is smearing how we see the galaxy. The smearing is actually so distinct that the long crescent galaxy has been named the Sunrise Arc, after the shape it appears to be. Something cool to think about is that just because the star is 12.9 billion years old, this doesn't actually mean that it and its galaxy are 12.9 billion light years from us. Since the expansion of the universe is now actually faster than the speed of light in some places relative to us, Earendel and the Sunrise Arc galaxy are actually almost 28 billion light years away. Earendel might be the most distant star we've ever seen, but it isn't the oldest star we've ever seen. Hubble did find that record holder too, an ancient star nicknamed Methuselah in 2013. And Hubble also discovered the most distant galaxy we've ever seen. The light from that galaxy took a whopping 13.4 billion years to reach us on the Earth. Back to Earendel, and the team involved was studying this Sunrise Arc galaxy, and they noticed a few interesting things. Firstly, there are these 2 spots here, which are actually both the exact same object, a so-called globular cluster of stars. And it's due to the gravitational lensing that we see the same cluster twice. Clusters at this distance are cool, but what's even cooler is this dot in the middle. That's Earendel, and the team have concluded that it's a single star visible in the Sunrise Arc galaxy. magnified 1,000-fold or more compared to its actual brightness by the natural magnifying glass that is the galaxy cluster between us and it. We wouldn't be able to see Earendel at all if it wasn't for the gravitational lensing causing the bright star to emerge from the glow of the galaxy it lives in. In fact, without gravitational lensing, it would be impossible to observe any star at such a large distance. Since Earendel is so old, one of the earliest stars that could have formed in the universe, we expect it to be composed of very few chemical elements, so it's pretty different to our Sun. We think Earendel is a population 3 star, which is what we call the first generation of stars to form. Our Sun is in the 3rd generation of stars, but we call that a population 1 star. I know, naming conventions in astronomy are bad. The difference is population 3 stars are probably only made of hydrogen and helium with no heavier elements. This is because the heavier elements like lithium and carbon and so on are made in supernovae that are the death of stars, or in neutron star mergers. But neutron stars are also just a different endpoint of dead stars. This all means that if you're the first stars to form in the universe, by definition, no stars came before you, so no stars have yet died. And so there's basically none of these heavy elements available to make you up. Studying Earendel could tell us all about these early stars and how they formed out of just hydrogen and helium. How will we do this studying, you ask? With none other than the James Webb Space Telescope, of course. The gravitational lensing should keep Earendel bright for many years, and because JWST is an infrared telescope, it'll be incredibly good at studying objects in the early universe anyway. Check out this video for more details on that, and this video to see the other reasons why Webb is an infrared telescope. Webb should be able to confirm that Earendel is a star as we currently believe, and it will also be able to see if it has a binary companion too. Something we don't know at the moment, but stars as massive as Earendel often do live in pairs. While Earendel looks as bright as a cluster of stars, we think it's just a single star, because the size we calculated for it is much smaller than a cluster usually is. Although, to be honest, even that's an ongoing discussion as we keep finding smaller and smaller young clusters. But this is something we'll leave to Webb to investigate further. JWST will also be able to use something called spectroscopy to see what elements are present in the sunrise arc. If, as we expect, we see very few heavy elements, then this will be great evidence that Earendel is indeed one of these rare, early, metal-poor population 3 stars. And we've never actually imaged these stars before, so it would be incredibly exciting to see. Webb will tell us the composition of the star, as well as its brightness, age, its size, all things we've never directly studied for such early stars before. The current estimate is that Earendel is about 50 times more massive than our Sun, and millions of times as bright. And this would make it one of the most massive stars known. But confirmation from Webb is still needed on this stuff. This excitement means that Earendel will now be one of Webb's first targets later in 2022. And the whole astronomical community is excited to find out what it sees. Webb might even find more stars just like Earendel from the very dawn of cosmic structure, and maybe even break this record for the most distant star. All we can do for now is wait. I hope you enjoyed this look at the Hubble announcement. Subscribe if you're new for all things astronomy and cosmology, including any updates we get from Webb later in the year about Earendel, and leave a comment or question below if you have anything to say. Until next time, stay safe team. I'll see you soon. Bye!